Video number 153 plus. Hello everyone. On March 5th of 2024, at the occasion of my 75th birthday, I was invited by my old friend Jean-Louis Nguyen to give a short informal talk about science at the regular meeting of the ROTARY Satellite Club of PATUMWAN Francophone. In this video, I simply share the contents of that talk. My title was, Why is not science more popular? This is a question which I have been asking myself for many years. And recently it appears even more crucial to me when I see the very small number of views for the YouTube channels dealing with real science. I mean, without aliens, artificial intelligence, dark matter, dark energy, quantum computing, and pseudo-scientific discussions on life after death. Before entering the main topic, let me introduce myself. I met Jean-Louis Nguyen about 60 years ago, since we were in the same high school class. 3 years later, our roads diverged since he decided to become a medical doctor, while I entered a very special French system which led me, after a complicated selection process, to become a mathematician. I entered the French National Center for Scientific Research in 1973, and after publishing some 150 papers and half a dozen books, I retired in 2014 with an emeritus status which allowed me to pursue my research activity until now. Actually, before starting my career as a researcher, I had hesitated between mathematics and physics. Immediately after retirement, I started to think about modern physics, as I had planned to do 45 years before. And I realized that modern physics faces a lot of problems. As for the title of my talk, I give the answer which seems most probable to me. Science is not popular because it has become a source of problems rather than solutions. Nowadays, people are pragmatic and they are not dreaming anymore. The time of fairy tales is over. This may look strange because, on the other hand, pseudoscience is rather successful. But there is no contradiction, because pseudoscience is treated as a kind of entertainment rather than a source of applicable knowledge. Modern physics is based on two major theories, relativity and quantum mechanics. The common point between them is complexity, which makes popularization very difficult. When you try to popularize a complicated theory, you need to simplify. But in science, simplification is always a lie. And the smartest persons which would be willing to learn those theories are precisely the most able to detect lies in a talk. This is one of the reasons why I shall not try to explain relativity or quantum mechanics to you. The other reason being that I do not master these subjects myself. I am not ashamed to say that, since the great Richard Feynman pretended that nobody understood quantum mechanics, and the great Albert Einstein said that a single experiment might prove him wrong. Now, the icing on the cake. General relativity and quantum mechanics are supposed to be incompatible theories. It is apparently a problem for physicists, but not for me. It is a very naive point of view to imagine that any physical theory can be exact. The contrary of exact, for a mathematician, is not approximate, but just false. And between two false theories, it is not surprising to find contradictions from the logical point of view. I do not believe that we shall ever find the theory of everything. Our world is far too complex for that. We must go on developing local approximate tools to study the important phenomena and improve our technology. But we have presently some indications that certain important phenomena are in fact global in essence, like inertia and quantum entanglement. This is a big problem for physics and technology of the future. Both quantum physics and relativity theory were devised in the beginning of the 20th century in order to solve some difficult problems which appeared in classical physics at the end of the 19th century, such as the ultraviolet catastrophe for quantum mechanics and the anomaly of Mercury's trajectory for general relativity. Since both theories seem to be successful at a very early stage, from that time until now, almost all international research was concentrated on those two topics. As a consequence, our students do not learn much about classical physics, which are most important for everyday life. And the research on the real systems is now mainly handled by high level engineers. I personally consider this excessive. Coming back to my rediscovery of physics after 2014, I started with the so called missing mass enigma. You probably heard about that under another name, which is dark matter. I realized that this problem forces us to reconsider very basic questions in physics, such as the origin of the gravitational force, a problem which remained open since Newton, and which is not at all solved by general relativity, contrary to what is often claimed by the aficionados of that theory. Between 2014 and 2020, I had some exchanges with professional physicists and some tricky engineers by mail or through scientific social media. I identified so many basic problems that I published a few preprints about dark matter, gravitation, black holes, and related questions. I did not even try to publish in peer-reviewed journals, except for the most mathematical parts of my investigations, which led to two mathematical papers and a chapter in a mathematics book on the interaction between elasticity and fluid mechanics. In the beginning of 2020, I planned to create a research seminar on basic questions of modern physics located in my research laboratory. But since the number of interested persons was too small, I went on working alone on physics, and after a while I created a YouTube channel on science popularization under the name Dead End versus Crossroads. Let me recall for you the aims and scope of this channel, which has now more than 60 videos in French with English subtitles and quite a few ones in English. You probably heard, rather often, that modern physics is going to a dead end. This is due mainly to the large number of unsolved hard problems and incompatibility between the theories describing our world at different scales. The modest object of this channel is trying to understand the underlying causes of this dead-end phenomenon. We shall ask questions rather than give answers, which remain the privilege of experts. In real life, when we experience a dead end, we can decide either to step backwards or to try an alternative way, which very often forces us to choose among the multiple ways of a crossroad. The second choice is more risky, but more ambitious. In science, it may have the advantage of promoting collaboration and long-term planning prior to immediate, perhaps illusory, benefit. Let me outline for you the main themes developed until now on my channel. 1. The cause of gravitation. 2. How could we exploit that cause to produce huge quantities of energy? 3. The strange properties of the photon. 4. The existence of huge non-singular black holes. 5. Why is the Big Bang theory difficult to believe? 6. Complexity and chaos. 7. Local versus global. There are, of course, many other topics covered in that channel, especially in connection with the observation of spatial telescopes, which confirm day after day my hypothesis, according to which the world's complexity is nearly infinite, and the word universe is a logical nonsense. As a conclusion to this short talk, I would like to emphasize some important points about cosmology which might help you to understand the present challenges of research in cosmology. 1. The dark matter hypothesis. The story starts in 1933 when the American-Swiss astrophysicist Fritz Zwicky, the co-discoverer of neutron stars, who was studying galaxy clusters, discovered that in the Coma cluster, the stars were rotating about 20 times too fast with respect to the total mass of the cluster. This implied that the mass was in fact 400 times larger than what was estimated from the light emitted by the stars. Zwicky logically concluded that most of the mass of the cluster was invisible, leading to the concept of dark matter. In the subsequent decades, it was found that several mistakes combined to produce the paradox, in particular, a wrong value of Hubble's constant, because Hubble's theory of cosmic expansion was just starting. After correcting all mistakes and after the discovery of several dark objects, such as black dwarfs and cosmic clouds, a discrepancy of 5 remained between the total mass of the cluster and the mass computed from its rotation velocity. In the 70s, 80s, another series of observations by Vera Rubin revealed another problem, currently referred to as the flat velocity curve problem. According to the standard theory of gravitation, the velocity of stars in a galaxy should decay near the boundary, but she found that it did not. Here also, the simplest explanation was the existence of unknown dark matter surrounding each galaxy. It was recently found that a huge gas cloud is indeed surrounding the Andromeda galaxy M31, and the same thing is conjectured for our own galaxy. But it is not clear whether the mass of the clouds is sufficient to produce flat velocity curves. Many astrophysicists are convinced that some kind of extraordinary dark matter of non-baryonic nature is the explanation for the gravitational anomalies, and many billion euros have been invested by European Union for research on exotic particles presently pursued at the CERN of Geneva, European Organization for Nuclear Research. Very recently, I learned that the existence of dark matter is also required to save the Big Bang model, which explains why many astrophysicists are maintaining that hypothesis against all evidences. 2. Recent findings relying on spatial telescopes. I always remember a sentence of the French astrophysicist and planetologist André Braic commenting the findings of the spatial probes Voyager in 1989. If you want to know what a planet does not look like, open an astronomy book of the 60s. I was certain that the same thing would happen for more distant objects when we would use more efficient telescopes. And, of course, it happened. Among other things, the GWST telescope found some galaxies comparable to the Milky Way, which already existed 300 million years after the alleged time of the Big Bang, a finding that challenges seriously the Big Bang theory, since it takes several billion years for a galaxy to reach the size of the Milky Way. Very strange objects were found, such as brown dwarf star with surface temperature below 0 degrees centigrade. That star radiates in the infrared, which makes it impossible to detect with usual optical telescopes. Relying on the catalogue of 1.8 billion stars in the Milky Way by the satellite Gaia, a team of 7 astrophysicists recently found that the Milky Way is about 5 times lighter than what we thought before. In addition, the velocity curves has been extended with respect to the measurements of the 70s, and the present shape no longer requires the existence of dark matter to explain it. Just a few days ago, it was found that an object considered as a star until now is in fact a very distant, huge quasar with an absolute luminosity equivalent to 500 billion suns. Each time a really important new discovery of the spatial telescopes is made public, I shall describe and comment it in a video of my channel. But there are some channels in which such observations are reported every day, which gives you an idea of the pace at which our cosmological landscape is presently evolving. We are living in a very interesting era, and as a conclusion, real science would actually deserve to regain more popularity. Thank you for your attention and welcome to questions.